Yes, you can.
Okay, so we will continue problems on chapter 12. We still have to practice on the final part. We introduced last time together what is the concept of relative velocity and relative acceleration. So let us practice on it. A train traveling at a constant speed of 90 kilometers per hour crosses over a road. If if the car A is traveling at 67.5 km per hour along the road, determine the magnitude and direction of relative velocity of the train with respect to the car. So here we have two particles in motion, the train and the car, and here both are doing rectilinear motion. Now they are asking us to determine v of train relative to car A. So we just have to apply the formula. The vector velocity of train relative to A is equal to the velocity of the train minus the velocity of the car. Okay. So now I should find the vectors, I should find their expression. For the train, my train is moving on a horizontal line. So its velocity, it's having only a component along I. So I can just replace Vt by 90I. While for the car, it's moving along an inclined path. So to find components, I should decompose into VA into two parts, one along I, one along J. Since I know that the angle here is 45 degrees, so this is 45, and then I can write simply that VA is 67.5 cosine 45I plus 67.5 sine 45J. Okay? So once I write the expression of each vector, all I have to do to find the relative velocity is to replace into the relative equation. Okay? And then I will take I term together, J term together. This will allow me to find the relative velocity vector. Now, if I want to find the magnitude and direction as I asked for, so I will do radical v relative x squared plus v relative y squared. So here you can find the total velocity vector. Then this is the x component, this is the y component. Then the relative velocity magnitude will be radical of 42.3 squared plus 47.7 squared. Concerning the direction, if you look at the signs, x component is positive, y component is negative. So we are in the second quadrant. So you can represent it, you can represent the vector by this one. And in order to determine direction, we need to give the angle with a reference line. So if I want to give this angle here theta, then I can simply say that theta is tangent minus 1 of this this dimension, which is equal to the absolute value of the y component over this one. So it's tangent minus 1, 47.7 over 42.3. Okay. Another problem. Plane A is flying along a straight line path, while plane B is flying along a circular path having a radius of curvature rho b equals to 400 kilometers. Determine the velocity and acceleration of B as measured by the pilot of A. So here we have two planes. One is moving straight on a straight line, and the other one is going through a curvilinear motion. It's a circle in particular. So, and we want to determine what is the velocity of B relative to A, and what is the acceleration of B relative to A. So first, the first step is to find, for the velocity, I should find VB and VA, and I can subtract. And the same for acceleration. To get the relative acceleration, I should find the acceleration of B, the acceleration of A, and then I can subtract. Okay, so AB relative to A is equal to AB minus A. Now, if I look at my figure, I have first A is moving upward, so it has a velocity in positive J, so VA is plus 700. J. Now concerning the acceleration, also the acceleration is same direction, same sense of the velocity. It's also upward, so AA is plus 50 J. Now for B I should pay attention that I have a curvilinear motion. So when I have a curvilinear motion, the acceleration will be divided into two components, one along UN, one along UT. And I have here UT. To determine UT here, it is along the tangent to the path. So if I draw the tangent line is vertical. So the velocity will be vertical, and it will be equal to 600 kilometers per hour. So I have that VB is plus 600 J. Now for the acceleration of B can be divided into two components. One along UT, this is UT. Okay, UT is along the tangent line. But as you can see, it's a deceleration for B since the velocity is upward while the acceleration is downward. So here AT is negative because it's opposing the velocity vector, and it's equal to minus 100 J. So I can say that AB tangential is equal to minus 100 J. While AB normal is perpendicular to UT, directed towards the center of curvature. So this is UN. So ABN will be along UN, directed towards the center of rotation. And to get its magnitude, we have the velocity at B. And of course, we divide VB squared by the radius of the circle. Okay, just pay attention for units. Here, I am working in kilometer and hour unit. I am keeping the velocity in kilometer per hour, and I'm keeping the acceleration in kilometer per hour square. So in case, for example, the radius was given in meter, make sure to convert unit. Okay, so AB normal here is equal to 600 square, which is VB. So 600 square over the radius of curvature at B, which is 400, along I. Okay. And in this way, I can now add the two to get AB vector. So AB vector will be the summation of both. And now, once I have all my vectors, I can just replace to get the relative velocity and acceleration. So as you can see here, we started by the velocity relation. We replaced VB by 600, VA by 700. We got that the relative velocity is minus 100. It will be along J. And now for the acceleration, after getting AB normal, we got that AB is AB tangential plus AB normal. Okay, so here it's Just let me make sure of AB tangential here comes the figure. So for AB tangential, it's minus 100J. Okay. So now, if I replace in my equation, so this is AB tangential minus 100J. This is AB normal, 900I, and equals to AA is 50J plus AB relative to A. This equation will allow me to get the relative acceleration vector, and then I can find the magnitude and the direction. Okay? Any question on this? Now, in this problem, they gave you a simple scenario. We will do together a small modification to see what to do. In case, for example, instead of giving me the position of B when it is just here, in a way that UT and UN are coincident with IJ, they can give me, for example, this position. If B is, let's say they told you that the angle here is 30 degrees, and B is at this location. Okay, so the technique will be the same. You should divide your acceleration into tangential component along UT and normal component along UN, while your velocity will be along UT. So if I take the same numbers, let us say that the velocity is 600, but now it will be, since UT is inclined, then velocity also will have two components along IJ. So I can first express velocity and acceleration function of UT-UN, and then I project UT-UN on my frame. So velocity vector then will be equal to 600 UT. Now for vector UT, to find its expression, I go back to the geometry of the figure. They told me that this angle here is 30. So if I do here the horizontal, this is 30 degrees. Okay, this angle is 30 degrees. So I can replace UT, I can project UT on IJ. The projection of the UT along I will be, because this angle will be 60. So along I have 1 cosine 60I, while for along J I have plus sine 60J for UT. So I can replace UT by cosine 60I plus sine 60J. So in this way, I got the velocity vector. Now, I will do the same for acceleration. For AB tangential, it's minus 100 UT, and I replace UT by its expression. While for UN, so for AB normal, it's VB squared over rho times UN. And UN vector should be decomposed into IJ components. So as you can see here, UN is doing an angle of 30 degrees with I. It has a positive I component, a negative J component. So I can replace UN by cosine 30I and minus sine 30J. Minus sine 30J. Okay. Any question on this? Okay. So this is chapter 12. We are done with chapter 12. I will start today with a new chapter, chapter 13. You will see that once you understand chapter 12, the other chapters will be easier. And it's just now how to apply Newton law. But if we understand well the rectangular components, UNUT frame, how to deal with it, then it becomes simple to solve problems from chapter 13. And in general, the chapters are combined together. So in one problem, you might need to use several chapters. So I will open a new session to start the new chapter, okay?
Doctor, so we're not responsible for the rest of the slides?
Look, في slides not included اللي ما شرحته you are not responsible of and هلا بهيدا البروبلم هون ما في هول solution بس okay? we don't have anything else في part بس قفيتها هي polar coordinates بس أنا على البلاك بورد حطيت لكم شيلتها من ال I think من ال PDF أو in case not قايلت لكم إنه you should not cover this part okay?
Okay, okay. Thank you.
Welcome. Okay. Yeah, let us open a new session to continue.